Hello students! So this little video here is about the standard form of quadratic functions. Most of you should already be familiar with what the standard form for quadratic functions look like. It could be written using that function notation f of x, but again that standard form is ax squared plus bx plus c. Again, they may use f of x, or they may replace that with what's commonly, what we may commonly see as y, right? So they may say y equals ax squared plus bx plus c. Or, again, it could also be considered standard form if that equation is set equal to 0. And so if it was 0 equals ax squared plus bx plus c. So we're going to look at quite a few things in this video, and we'll start off by looking at rewriting other quadratic forms in standard form. So some of you may recognize this particular form here in example 1, and so you may be looking at it and you may be saying, okay, well this is in it's in some kind of factored form, because I can identify, certain factors here. So it's in some type of factored form. And you're right if you said that. Maybe a formal name for this particular form would be called intercept form. Again, intercept form. And we'll talk a little bit more about that in a different lesson. But let's look at example 1 here. So if we were asked to write this function h of x in standard form. So I know that you're probably looking at this and you're saying, okay, there's a -3 here. There's this part in the parentheses, and then there's another part in parentheses. So if you're looking here, there are 3 different things that we need to multiply here. We have a -3 being multiplied times this first part in the parentheses, also being multiplied times this last part in the parentheses. What we need to make sure that we know is that when we are multiplying more than 2 things, guys, something times something times something, and it could be more than just 3 things, but you can only multiply 2 of those things at one time. So you need to choose which of those things that you want to multiply first, because again, you can only multiply 2 things at a time. So you got to make a choice here. Again, because you can only multiply 2 things at a time, you need to choose. Okay, do I want to multiply these first 2 things together and do that first, or do I want to multiply the last 2 things together and do that first? It really doesn't matter which 2 you decide to multiply first. Again, I'm just going to go in the order that it's written, not that you have to do it in the same order that I choose it. But again, I'm just going to do that there. So I'm going to multiply these first 2 together. The -3 multiplied times the x minus 8. So when we multiply those 2 together, we wind up getting here, and we got to distribute the -3 to that. So we get -3x plus 24. All right. So when we do that, guys, this part here, that last part that we haven't multiplied yet, it's still there because we haven't multiplied it in yet. So we're going to have to actually take that and we're going to have to multiply it times the result that we just now got. So we just bring this part down, the part that we haven't multiplied yet, and we're going to multiply that next. All right, so now we're going to take this result that we just now got, and we're going to multiply it times this third thing, times the x plus 7 in this particular example. All right, so we should be familiar with how to multiply these already. Either you're going to use the FOIL method, or you're going to use extended distribution, or you're going to use the box method, right? So again, it doesn't really doesn't really matter which method you prefer or which method you're going to choose. But again, as long as you make sure that you multiply it the right way, correctly, using one of the methods that you have learned to do this. So this is going to give you negative 3x squared. Let's see, minus 21x, and I'm not going to combine like terms just yet. Plus 24x. And 7 times 24. Let's see, that should give you 168, I believe. Yeah. All right. And so then when we combine these two like terms, we end up getting here that negative 3x squared plus 3x plus 168. And now we have written this in standard form. So again, because you could only multiply two things at a time, guys, we had to multiply. We had to choose two things to multiply first, and so we did that. We went on ahead and we distributed the negative 3 to this first set of parentheses, and we got the result of negative 3x plus 24. And so then we took that result, we brought down that last thing that we had not multiplied yet, and we had to actually multiply that in now. So we multiplied that last thing times the result that we just now got. And so we wind up, now we do actually have this written in standard form, okay? All right. Okay, so next we are going to look at another example of rewriting other quadratic forms in standard form. All right, so let's look here at this example. All right, so it says here, write k of x in standard form. So this one is a little bit similar to the first one, and yet it is not at all like the first one. And so this is a different form for quadratics. Again, the technical form for that first example was it was written in intercept form at first. This one is called vertex form technically, but again we'll have later lessons talking specifically about these other types of forms. But again, we're going to write this equation in standard form, this function in standard form. And so you guys notice here that there's a number in front here that's being multiplied times this quantity that's in parentheses, but this quantity that's in parentheses is being squared. And then you've got something here on the outside that's being subtracted. So guys, if we want to write this in standard form, remember guys that a lot of you are going to be tempted to try to distribute this 6 here. Please, I'm begging you, baby, please, students, do not try to distribute this number into this quantity that is being squared. You cannot distribute something into something else that's being squared. Okay, you can't distribute into a set of parentheses where the exponent is greater than 1. So again, folks, you do not try to distribute into a parentheses that is raised to a power that is not equal to 1. So in other words, folks, because this parentheses here is raised to a power of 2, and that power or exponent is not 1, because this power for this parentheses is not 1, you cannot distribute this number into this parentheses. So, but what you can do is you can go ahead on and write out, you can write out this exponent, you can write out this parentheses with the exponent as repeated multiplication. Guys, remember that anytime that you've got something squared, that means that you are technically doing repeated multiplication. You are squaring it, meaning that you are multiplying it times itself. Okay? Okay, so let's go ahead on and do that. Let's rewrite this here. Exponent, ew, that's sloppy. Let's rewrite this exponent here as repeated multiplication. Alright, so let's do that. We've still got the 6 in front here, but if we write this as repeated multiplication, the exponent's 2, so that means that we're multiplying it by itself, and we write it out twice. Okay, so that handles that part. And now, if you choose to, now you can distribute the 6 into one set of this parentheses. So again, guys, the reason why, the real reason why we couldn't distribute into the parentheses was because we were following order of operations. Technically, guys, we were following order of operations. You guys remember PEMDAS? PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, order of operations. Again, you cannot, we couldn't multiply there until after we had handled that exponent first. Alright, so again, that's that though. So now, guys, we need to continue and pretty much continue in what we started, continue using the order of operations, again, that PEMDAS, and let's multiply those factors 2 at a time. Because remember, you can only multiply 2 things at a time. So continue to multiply those factors 2 at a time before you do any subtracting. Because again, you need to follow order of operations. Okay, you don't subtract before you multiply. So let's multiply these first, and then after we get finished multiplying, we can subtract. Alright, so we do that 2 at a time. Let's go ahead on and distribute that 6. When we do that, we get 6x minus 18 as a result, or the product of doing that. And remember, we bring down this other factor that has not been multiplied just yet, and then we multiply that times this product that we just now got, times that result. And we still do not subtract anything yet. Okay, bring down the subtract in part 2, because you're not going to subtract anything until you finish multiplying. Alright, so now we're going to go ahead on and multiply these 2. Alright, so when we do that, you should already know which method you want to use, whether that's going to be the FOIL method, the box method, or extended distribution. That's up to you. It's your cup of tea. You're the one who got to drink it. Alright, just make sure you're doing it correctly. 6x squared minus 18x again plus 54. Ooh, that's a sloppy 54, ain't it? Try that again. 54. Alright, that's better. Alright, and we still gotta bring that minus 11 down, because we have not subtracted anything yet. But now we are at a point now where we can actually subtract. And actually all that we've got left is actually adding and subtracting those terms. And so we're going to go ahead on and combine our like terms here. Right? And so let's do that. Let's simplify, combine like terms. Okay, so let's combine these like terms here. All right, so we've got negative 18x, negative 18x. That gives us negative 36x. Of course, we still got this part here, and the 6x squared. And we've got the 54 and the negative 11. When we combine those two like terms, 54 and negative 11, we wind up getting 43, positive 43. All right, and now we can say that this particular function has been rewritten in standard form. Again, that standard form is that form ax squared plus bx plus c. And again, it is in that form. And technically, it is still, it's still written as k of x equals that. Okay. Okay. So next, we're going to look at certain components of that standard form. We're going to look at certain parts, certain pieces of that standard form of quadratic functions, and we're going to look at what particular key features that quadratic form can determine, or what key features the components of a quadratic form can determine. So, guys, when we are when we're talking about certain key features that can be identified using the standard form, what types of key features can be identified? You know what, y'all? That's a good question. All right. So, you can identify the y-intercept. You can identify the axis of symmetry. And for those who don't know what that is, we'll explain what that is in just a moment. You can identify the x value of the vertex. If you don't know what a vertex is, we'll explain that in just a moment, what it looks like and everything. You can identify and determine whether the graph will have a relative maximum or a relative minimum. Like I said, if you don't know what those are, relative minimum, relative maximum, we'll explain that to you. And you can also determine exactly what the maximum value or minimum value is. Do I really have to say it, folks? Do I really have to say it? Of course I'm going to say it. If you don't know what those things are, we're going to explain those to you. So we're going to try to go in that particular order. And we're going to talk about first how to identify the y-intercept from that standard form of a quadratic function. All right, so we'll go in that order. How do we do that? Man, that's a good question. So, guys, you should recall, that standard form either is going to be f of x equals, it's going to be written with f of x equals, or it's going to be written with y equals, or is going to be written as 0 equals. But again, it's going to be ax squared plus bx plus c. And so, guys, the particular part of this this standard form that is going to allow us to identify the y-intercept is that c value, that constant term. And again, of course, I'm going to show you an example because I never want to leave you with something that looks as abstract as that. So again, I'm going to show you an example of how you do that. Okay, so let's look at a quick example here. So let's say we were asked to identify the y-intercept of this equation here. Again, folks, remember. We said that when you've got a quadratic function, in order for it to be in standard form, it could either be written where you've got like this function notation f of x, or it can be written with a y equals. And again, if it's written in one of those two ways, then it would be easier to make sure that it's in standard form, because all you'd have to do is make sure that the terms were in the right order. again, that ax squared part coming first, and then in the middle would have to be your linear term with just the x, and then the last thing would have to be the constant term with no variables. But again, remember that there's a third way that it can be written in standard form, not just f of x or y equals, but it could also be set equal to 0, and it would still be considered standard form of this quadratic function. So we need to get this particular equation here set equal to 0, and then we need to make sure that each of the that the terms are ordered, or that they're written in the right order. So again, guys, with this particular equation, since the equation is not written with an f of x or y equals, again, we're gonna have to make sure that we set our equation equal to 0, and then make sure that your terms are in the right order, in that ax squared plus bx plus c form. Again, it does not matter which side of the equation you get set equal to 0, as long as one side, either side, is set equal to 0. All right, so I'm going to subtract this 3x squared from both sides. It's going to cancel out here, and we're left with -8 equals 2x minus 11 minus 2x squared, and then we've still got to get this -8 to cancel out, so that we've got 0 on one side of the equation. All right, so now let's see here, we're adding 8 to both sides. So now we've got this is equal to 0, and now we've got left there 2x minus 3 minus 2x squared. So the equation is equal to 0, but as of right now, these terms are not in the right order. Clearly, they're not written in that ax squared plus bx plus c form. Again, the exponents need to be ordered from the highest to the lowest. So the highest exponent should come first, that part with the x squared. So let's rearrange this, and let's just switch up the order. Let's use the commutative property. Switch the order here. You keep the signs that are in front of each of these terms stays the same. This is -2x squared. It stays as a -2x squared. Okay. This was a positive 2x. It stays as a positive or plus 2x. This was a -3. It stays as a -3, as a -3. All we're doing there is switching the order of the addition and the subtraction, but the signs, they stay the same. All right, so now it is written in standard form, and now we should be able to clearly identify what that c value is, what the value of c is. In other words, we should be able to identify what that y-intercept is. So in this particular case, the y-intercept is clearly going to be, yep, you got it, folks. It's going to be -3, because our c value here, that value of c is -3, and so that is going to be our y-intercept. -3 is the y-intercept. I'm going to shorthand y-intercept. Next, we're going to look at what an axis of symmetry is, and how do we identify that axis of symmetry when we've got a quadratic equation or a quadratic function written in standard form. Okay, so for those who may not know, again, an axis of symmetry is a straight line, and sometimes that line is not shown, and that's more often than not. That line will more than likely on certain graphs it would not be shown. But again, it's a straight line that appears to split an object or a graph into two symmetrical halves. It's important that you recognize, if you don't already know, that all quadratic functions pretty much have the same shape. They've all got a U-shaped graph that's usually referred to. That U-shaped graph is usually referred to as a parabola. And again, for all, pretty much for any type of quadratic function, the axis of symmetry is always going to be a vertical line. So yes, I'm gonna, okay, yeah, let's try that again. I'm gonna put this vertical line right here. All right. And again, usually, it will not be actually that vertical line, or that axis of symmetry will not usually be visible to you. But again, in this case, we're going to make it visible for you. Right down the middle, splitting the graph into two symmetrical halves. And what I'm doing here may not be exactly perfect, but it is going to be close enough. All right. So again, for those who are wondering what an axis of symmetry is, what you're looking at right now, this particular vertical line, this is an axis of symmetry. Okay? Alright, so the way that we can determine or identify what that axis of symmetry is based on the standard form for a quadratic function is we actually have to identify certain or we have to do a certain calculation in order to do that. Okay, so let's say that we were asked to identify the axis of symmetry of this function here. F of x equals 2x squared minus 12x plus 7. And so in order for us to do that, first off, guys, please realize that again, if we're asked to identify an axis of symmetry for a quadratic, again, automatically we're talking about a vertical line. So guys, when you identify that vertical line, you've got to give that vertical line, or you got to tell what that vertical line is by stating an equation. And guys, vertical lines, or the equations for vertical lines, are always written as x equals some number. So again, because this vertical line, this axis of symmetry, because it will always be a vertical line, you're going to need to give the equation for this axis of symmetry. And again, guys, the equation of a vertical line is always written as x equals some number. Okay, so again, in this form, in this standard form here, we identify the axis of symmetry by using this particular calculation. So the axis of symmetry will be using this equation. Again, the equation for a vertical line has to be in the form of x equals some number. So the axis of symmetry is going to be this particular equation here. X equals, and then we have to actually calculate this value. X equals negative b divided by 2a. So again, in this particular form, in this standard form, we should already recognize what our a, b, and c is. Yeah, because it's already in the right form. We should recognize this as our a value being 2, our b value is negative 12, and our c value here is 7. So all we should have to do here is substitute this here. Alright, so again, if we substitute those values there, we should be able to get exactly this equation for the axis of symmetry. Alright, so since this says negative b, again folks, when we did the quadratic formula, we had something similar to this, and remember I told you that this negative b is not really a negative b. What this means is the opposite of b, meaning that you have to use the opposite sign of whatever the b value is. So if we use the opposite sign of what this b value is, that is going to be us using or this what you might call negative b. The opposite sign here of that would be us writing positive 12. Okay, so this would be positive 12 there. So this is positive 12 because again we're doing the opposite of b. So that would be positive 12, and at the bottom we're going to divide that by 2 times a, which is 2, right? 2 times 2, which is 4. So we're talking about taking 12 divided by 4, which winds up being 3. However, remember folks that again we need to write this as an equation. So again, as an equation, we write out the fact that the axis of symmetry, and we have to write it as an equation. Please do not put that the axis of symmetry is 3. If you just put a number for the axis of symmetry, you are so wrong. Okay? Whether it's on Delta Math, whether it's on any other type of assignment, you are so wrong. Okay? Whether it's on your final exam, you are so wrong if you just put a number. You have to put an equation as the axis of symmetry, because we are talking about a vertical line when we're doing a quadratic function. Okay, so the equation of this vertical line is x equals 3 in this particular example, okay, for the function that we've got here. F of x equals 2x squared minus 12x plus 7. All right. So, guys, next we are going to look at how we can identify the x value of the vertex. And for those who may not understand or may not know what the vertex is in a quadratic function, we'll talk about what we mean by vertex. So, the vertex of a quadratic function is the point in the center of a graph that's located where the axis of symmetry intersects the parabola. So again, as you see here, we've got a parabola, we've got an axis of symmetry just like what we did before. And again, you can see the exact place where that axis of symmetry intersects with this parabola. And again, that particular point is, that's what we refer to as the vertex of a parabola. And again, the vertex is an ordered pair or a coordinate point, just like every other point on the graph of the parabola. But again, we just happen to be focusing on just this one point for right now. But every other point up here, of course, is an ordered pair where you've got an x value and a y value. So, guys, since this vertex and that axis of symmetry, they actually have the exact same x value, since that is true, then the same exact thing that you use to calculate the equation of the axis of symmetry is the same thing that you're going to use to calculate the x value of the vertex. So the x value of the vertex here is going to be negative b divided by 2a. And again, guys, here is just a little bit different, because even though we're using the same calculation, that negative b over 2a, again, for the x value of the vertex, we don't have to write this x value as an equation. But we do, and we did have to write the axis of symmetry as an equation. So again, we're doing technically the same calculation, but the difference is we don't have to write this x value as an equation. And we did have to write the axis of symmetry as an equation. So again, let's say that we were doing the exact same equation, the exact same function as we did before. So guys, when we use the exact same equation, the exact same function, technically that we used for when we were doing the axis of symmetry, that exact same function, 2x squared minus 12x plus 7, we wind up getting, because we're doing the exact same calculation as the axis of symmetry, we wind up getting that the x value of the vertex is 3. But again, folks, remember that this is written differently than the result of the axis of symmetry. Remember, the axis of symmetry is an equation, and because it's an equation, it has to be written as an equation, x equals. Okay, so, but again, for the x value of this vertex, you don't have to write that as an equation. You just write it as the value of the of that. It's just 3. That's the x value of the vertex. All right, so the x value of the vertex is 3, and remember, folks, that we can find the y value here. Remember, we've done evaluating functions, and so if you want to evaluate this function and find out what the function value is, or what the y value is at this particular x value, you can do that. And so again, it's not too much of a stretch for someone to ask you to evaluate this particular function and find the y value of the vertex if you've already figured out what the x value of the vertex is, right? It's not too much of a stretch to do that and to ask you to do that. So remember that you can find the y value of the vertex. Okay, so again, folks, remember that that if we are going to evaluate this function and find the y value of that vertex, remember, folks, that the y value of the vertex here, and if we use the function notation, that y value of the vertex would be the same thing as us finding f of 3. It would be us finding this function value, or the y value, given this particular x value. So when we plug in, remember, finding f of 3 means that we substitute or plug in 3 everywhere in this equation, everywhere in that equation where we see x. So remember that means that this would be 2 times, okay, instead of writing x, it would be 3 squared minus 12 times, and instead of writing x, this would be 3, and this would be plus 7. Okay, so 3 squared gives us 9, and 9 times 2 is 18. Negative 12 times 3 gives us negative 36. course, that's still plus that. And 18 minus 36 gives us negative 18. And negative 18 plus 7 is negative 11. So the y value of this particular vertex, the y value of the vertex here is negative 11. So again, we were able to identify the x value of the vertex, and then we can still, of course, evaluate the function by plugging in that x value, and we can get out what the y value of the vertex is. So again, that's not too much to ask. Okay. All right, and so again, the whole vertex there is 3, negative 11. All right. Okay, so next up, we're going to look at how do we determine whether or not a quadratic function has a maximum or minimum. How do we determine whether or not it has a relative maximum or relative minimum based on the based on the standard form of that quadratic function? So when we're trying to determine relative maximum or relative minimum, first off, guys, some of you might be kind of sitting back, okay, Mr. Starkey, and some of you might already be familiar with what a relative minimum or relative maximum is, but some of you might be like, yeah, okay, what exactly is a relative minimum or relative maximum, Mr. Starkey? Really? Seriously, what is that? What is this? So, again, a relative minimum is the lowest point on a graph compared to the nearby points to the left and right. And so here you can see here that we've got this this parabola, this U shape, and you can see that we've got this arrow pointing here to this lowest point on that parabola compared to all of the nearby points to the left and right. That is the relative minimum for this graph here. And guys, on the contrary, a relative maximum is the highest point on a graph compared to the nearby points to the left and right. And so you can see here that we've got this arrow pointing here to this highest point on this parabola compared to all of the nearby points on the left and right. So again, this point here would be considered the relative maximum. So some of you might be looking and you might be saying, oh, okay, Mr. Starkey, why does this relative maximum and this relative minimum here look the exact same way that the vertex did? You're absolutely right. So again, guys, for a quadratic function, yeah, the relative minimum or the relative maximum will be the actual same point as the vertex. And something else that you need to make sure that you know is that a quadratic function, it can have either a relative minimum or a relative maximum, but it cannot have both. It has to be either one or the other, not both. And again, whatever that relative minimum or relative maximum is, that's going to be the exact same point as the vertex. All right, so again, guys, that's what relative minimum is, what a relative maximum is, and for us to be able to look at the standard form of a quadratic function and tell what and tell whether or not there's going to be a relative minimum or relative maximum. All right. What we need to look at with that standard form is we need to look at that a value, at the value of the a. All right, so a quadratic function will have a relative minimum if the value of a is positive, but a quadratic function will have a relative maximum if the value of a is negative. All right, so again, based on the value of the a, all right, for this particular function here on the left side, the a value here is 1. The b value just so happens to be 0 because, again, there is not a term that has just x written with it. And then, of course, the c value is -7. But again, because the value of a here is positive, that lets us know that we're going to have a relative minimum. Okay, so the shape of this parabola is going to be a U shape that opens upward, that opens up, and it is going to have a relative minimum because the value of a was positive. Okay, over here, when we identify a, b, and c, our a value is -13, the b value is 50, and the c value happens to be 0. And again, we know that c value is 0 because this one is not written with any constant terms. So again, and both of these equations are in standard form already, y equals, and the terms are in the right order, and this one is set equal to 0 and the terms are in the right order. Alright, so again, here, since the value of a was negative, ooh, that is sloppy, but it's going to be alright for the day. Since the value of a here is negative, then again, that means that the parabola, the U shape, is going to open downwards. And since it's going to do that, that means that it's going to be a relative maximum. Okay? So there you have it with relative maximum, relative minimum. One more thing that we need to discuss, and then we're going to call it quits because it's getting kinds of late here. What is a minimum value or what is a maximum value? So again, we just talked about what a maximum relative minimum is and what a relative maximum is, but what is a minimum value? What is a maximum value? And so we're going to talk about. Okay, so a minimum value is going to be the lowest function value. So let's say that you were asked to find the minimum value of a particular function. In other words, they would be asking you to find the lowest function value. And remember, function value, when we say that, we mean the y value. So a minimum value would be where you're finding the lowest y value or the lowest function value, the lowest y value there. And guys, you're only going, as far as for quadratic functions, you will only get a minimum value, a lowest y value, when you have a minimum, a relative minimum. So again, folks, if you're asked to find a minimum value, we're pretty much asking you to find the lowest function value or to find the lowest y value of that particular function. And remember, guys, you are only going to have a minimum value if you've actually got a relative minimum. So if your vertex is a relative minimum, then what that means is that you're going to, in other words, that your minimum value is going to be the y value of that vertex, or that lowest y value there. So again, so the y value of the vertex here, if it's a minimum, we're talking about y value of the relative minimum. If we're talking about a minimum value, so we're talking about the y value of the relative minimum, that would be a minimum value, right? Or we're talking about the y value of the maximum, or yeah, which would be the maximum value. Okay. Well, folks, I do hope that this has been helpful to you. Well, we've talked about again what some of the different types of key features are that can be identified based on the standard form of a quadratic function. And again, we've talked about how to identify y-intercepts. And again, we've said that the y-intercepts are going to be your the value of c. We talked about how to identify the axis of symmetry. We said that for quadratics, that's going to be a vertical line, and for the equations of vertical line, you've got to write it as an equation as x equals negative b divided by 2a. And we said that the x value of the vertex technically has the same exact calculation as the axis of symmetry, but again, it's different because for a vertex, or for the x value of the vertex, you don't have to write that as an equation. But again, for the axis of symmetry, you do need to write it as an equation, as x equals some number. And then we talked about again what relative minimums are, what relative maximums are, and how to identify whether or not you're going to have a relative maximum or relative minimum based on the standard form for a quadratic equation. Again, we look at that value of a, and if the value of a is positive, that means that it's going to be a relative minimum. But if the value of a is negative, that means that we're going to have a relative maximum. And then, again, we talked about, lastly, when is it, or if we're asked to find a minimum value, we're talking about pretty much, in layman's terms, we're asking you to find the y value of the relative minimum. In other words, find the lowest y value if there is one, right? And then, of course, the opposite is true if you're asked to find a maximum value. All right. Again, folks, I hope that this has been helpful to you. That's all. Good night.